Okay, so they asked us to state the domain and the range. Before you do that, you have to identify the function. I'm hoping that you realize that it's the cube root. So x, the domain is going to be x is an element of the set of real numbers, and the range is going to be y is an element of the set of real numbers. That is true for all cube roots. Okay, so look for number 9. What I did is I already put those equations into my graphing calculator, and I came up with the maximum and minimum. All right, and so what I'm going to do now is notice here we are decreasing and then increasing, decreasing, and here I am increasing, decreasing, increasing, and then decreasing. Okay, so they want to know where we're increasing, so let's go back to 9a. And so I'm going to start at, I'm sorry, my pen takes up too much room. Negative infinity to 1, excuse me. That is not where it's increasing. Let me start again. It is increasing from negative 4 to 2.33. Now remember, we only talk about the x's. Where it is decreasing is negative infinity to negative 4, and then it's decreasing from 2.33 to positive infinity. Okay, if you don't remember this, you need to go back and review it. Okay, now let's go do B. It's increasing first. So I always start from the left. Negative infinity to negative 1. And then it is increasing from 0 to 1. Okay, now it is decreasing from negative 1 to 0. And from 1 to positive infinity. All right. Okay, so for number 10, remember the number of zeros is the degree. So for A, the degree is 5, and I graphed it, and I did a little sketch off to the side. It only crosses the x-axis once, so there's one real 0, but there's 4 imaginary. And remember, the answer to imaginary numbers has to be an even number, because they come in pairs. Okay, so look at B, the degree is 4. It never crossed the x-axis, so therefore there are 4 imaginary zeros. Okay, so let's talk here about the possible rational deals. It's always the constant divided by the leading coefficient. So in this case it's 1. So it's going to be, I'm going to have 1 at the bottom. Remember, it's plus or minus, don't forget that. Because the leading coefficient is 1, so there's only 1. But now we got to do the multiples of 64. So that's 1, 2, 3 doesn't go in there, 4, 5. No, 5 doesn't go in there. They're silly shorts. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I think the next number is going to be 32. And then 64. So 1 times 64, 2 times 32, 4 times 16, 8 times 8. So those are all the possible combinations. So it's going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32, plus or minus 64. All right. Remember, they're possible zeros. It doesn't mean there are going to be zeros. Okay, let's go here to number 11. They want us to find the inverse and graph the inverse and the original. So I'm going to do this is a cube function, and my vertex is at 2, negative 2. So I'm going to go over 2, down 2. Now, excuse me, I can't get exact. Go up 1, over 1, down 1, over 1. My cube root is going to be like that. All right, so now I'm going to do the inverse. So I'm going to do that in a different color. And so the inverse is going to be a cube root, and the vertex just switches places. So -2, 2, up 1, over 1, and so it's going to be like that. Okay, and they should be symmetric to the line y is equal to x. Okay. Now here for B, they want us to state that these are inverses, and there's only one way to do this, and a lot of people get this wrong. All right, and so what you have to do, you have to put one function inside of the other. So I'm going to put G inside of F only because F comes first. So I'm going to do 2, and then here instead of x, I'm going to do the cube root of x minus 2 divided by 2 cube, because that's x plus 2. All right, so I'm going to do cube and cube roots undo each other, so I get 2 times x minus 2 divided by 2 plus 2. These two cancel out, so I get x minus 2 plus 2. These two cancels out, I get x. Therefore, since my answer is x, these are inverses.